Okay. So define pressure. Pressure is force per unit area. That's pressure. Now it says show the SI base units of pressure are kg, meter, -1, second, -2. So we could do that easily because then, so pressure is force over area. Force units are kg, meter, second, -2, divided by meter squared. So meter and square will cancel out, so it will leave us with meter, -1, second, -2. So that's how it's shown. All right. Now, again, now in this question, if you see, there is a root. Okay. So first of all, I'm going to remind you that remove root. Always do that. So if you do that, then basically it's going to be like, you square on both sides, right? Like this, like that. So it's going to be m squared over d squared equals to k squared c squared and rho and p. All right. Now it says determine the base units of c. So we'll make c squared the subject. And when you do that, it's going to be c squared equals to m squared over t squared times 1 upon k squared times 1 upon rho times 1 upon p. Like that. Okay. Now, if you look at it, k is a constant with no units, so we will ignore this one. So just ignore. Since it has no units. Okay, so I'm writing it so you remember later on as well. Now what you're going to do is, this is going to be, m is basically mass and the d is time. So mass is in kg. So kg squared over second squared times, I'm going to ignore this, I'm going to use this. So density is kg per meter cube times 1 upon kg meter -1 second -2. So that's what we have already done top, so we don't have to do anything again. Just write c squared. Finally, what you're going to do is you're going to write, make everything like positive, just dissolve everything, like kg squared over second squared times meter cube over kg times meter and second square divided by k. So if you see, there are 2 kgs on top and 2 at bottom, so which means these and these cancel out. And there are second square and second square also cancel out. And only the meters are remaining, so there are 4 meters, right? So meter cube and meter would be meter raised to power 4. Take the root again, because you need c, so it's going to be a meter square. So that would be the base unit sign. Now I just want to tell you here that keep on writing c squared, so you do not forget. Okay, like that.
Okay, sir, let me write this computer.
Yes. Okay. Very well. Please let me know if you have a question here. Anything you'd like to know, anything you'd like to discuss, please let me know. All right. So, Aman, everything is clear? And Patija and Javeria,
So
Yaya, you
Yes, sir.
understand? Okay,
Yes.
very
yes,
good.
sir.
Ayan and Zahan. All right. So then should I go forward?
No, sir, I'm writing this.
Okay.
Sir, if you bring m square over t square to the other side,
Mm.
won't the
Yeah,
sign change?
I never did. It was already on the left side.
Sir, can you go up?
Up where? This is where we
Yes, sir.
started.
No, sir, the last question. Can you solve that one?
That is the homework. I'll check that one.
Okay, sir.
Okay. Now should I go forward?
Mister, from the third step to fourth step, you brought meters upwards and you changed the signs. Is that what you did? Sign
Yes.
on the power.
Yes.
Okay.
Made everything positive. Yeah.
Then, sir, you can move on.
Okay. Now, the next thing we're going to do is homogeneous equations. All right. So let me just explain what homogeneous equation really means. And then we're going to, continue to do this. So homogeneous equations mean that the left-hand side of an equation should be equal to the right-hand side. And what we're looking at is the units in each term must be same. All right, so let's just look at this. For example, if I say there's an equation like pressure equals to rho GH plus force over area, that's suppose this is an equation. And now we want to know if this is homogeneous or not, right? So to prove it as homogeneous, what we're going to do is, we know that pressure is kg meter minus 1 second minus 2. Density is kg over meter cube times g is meters per second squared with acceleration times h is meters plus force over area, right? So force is kg meters second minus 2 and area is meter square. Now let's go on and simplify this. So kg meter minus 1 second minus 2 equals 2. If you look at it, there are 2 m's on top and 3 at the bottom. So these 2 will be cancelled out with this. So we're left with kg meter minus 1 second minus 2. On the next one, meter on top cancel out with this. So it's kg meter minus 1 second minus 2. Now, if you look at the, I intentionally did with each different color, because if you look at them, you realize that all of these, this one, and this one, they have the same units. So we would say that this equation, so this equation is homogeneous. Is that clear, everyone?
Yes, sir.
So every single unit in every single term of the equation must be the same in terms of SI base units, and that will let you know whether it's homogeneous or not. All right, you can write this down, please, and then we'll move to the examples. Okay, now both Khatijas are here. All right, so I'm pretty much, yes. Khatija, you're late, and
Sorry, sir, I just came home. I'm sorry about that.
and the other Khatija, the Dubai one. Why were you not there yesterday?
Sir, I didn't know that the classes were starting from yesterday. I thought it was from 10.
Eh? Okay. Anyway. All right. Everybody's written it. Any questions? Should I go forward? Hiba? Do you
No, sir, wait,
understand?
just a minute.
Okay. All right. Hmm. All right. So yeah, should we go forward?
Yes, sir, yes.
Okay.
Yes, we.
Now, so now let's look at this question and see what they're asking. So first of all, they say the current in the wire I and charge Q passes 1 point and state the relationship between. Okay, fine. All right. This is basically current is equal to charge over time. Okay, this is the relationship you already know. In which of the quantities are the base quantities? Now, you see charge is in coulombs, so it's not a base quantity. Current and time are. So we could say I and T. Okay. Now, Now, it says that the current, the wire, due to electrons, each with charge u move with speed v. So this is charge speed, and there are n number of electrons per unit volume. So this is number of electrons per unit volume for having a cross section area S and current I. So it says what are the base units. So first of all, I is current, so it's going to be amperes, right? N is number of electrons. Number of electrons have no units, but it is per unit volume. So it means 1 divided by meter cube, because it's electrons per unit volume, right? So let me just write it this way. So you guys understand this. Just a second, let it sink. Yeah. Okay, I need water as well. Anyway, so it's saying N is electrons per unit volume. So anytime you do not understand term, you can just write it down. Electrons have no units. Volume is, so it would be 1 upon meter. Area is meter square. Q is charge. Charge is current into time, which is amperes seconds. And velocity is speed, v speed, so meters per second, like that. Okay, so now this will give us 3 marks, which is good. Most of this we did it in the in our list as well, so you can go back and view it. Now it says by considering the homogeneity, that if I write the equation I equals to NSQVK, it's saying considering the homogeneity, which means that the units on left hand side should be equal to the units on right hand side, right? On the left hand side, we have only one unit, which is ampere. So what we're saying is that all of these must also be equivalent to amperes. This is what we mean. So what we're going to do is we're going to first of all put in the units of these equations together, and then we're going to check, we're going to put it against amperes, right? So let's do that. So ampere is equal to N is 1 upon meter cube, S is meter squared, Q is ampere seconds, times V is meters per second, and whole power of K, right? With the power, we need to find K. Now what you're going to do is you're going to try and cancel out most of the things. So this is the tricky part. So let me just go through this. So here, ampere equals to this meter square can be cancelled by cube, right? So it is going to be just 1 upon meter times ampere seconds, right? Times, let me just move it to the side. It's getting a bit clunky. Wait, let me remove it here. Oh no, I put it differently. Here, okay. So what I'm going to do is I'm going to say this is 1 upon meter times ampere times seconds, and it is M over K and S over K, because power can be, just put on each of the units there. Then the issue would be that we need to actually solve this. And if I solve this, this is going to be ampere equals to amperes. And now S can go up. So it's going to be basically M has 1. So K minus 1 times, right? Times, see this. S, it has power of 1. So 1 minus K. Do you guys understand what I'm doing?
Yes, sir.
Okay. Now think about it.
So wait,
On the,
with
yeah.
M you did K minus 1.
Yeah. Because this k is on the top, right? So when you bring it upwards, this m1 is going to be subtracted from this, no? Do you understand what I'm saying?
Oh, okay. Yes. The
Yeah.
bases
So
are same.
just the indices that you've done in math. So you need to follow along. Just look at it for a moment, okay? Just look at it and let me know if you do not understand something here, because this question is very, very hard and very, very important as well. Sometimes they give crazy questions, so we have to be prepared for that. Anyway, I needed a tissue. Right. Okay. All right, now. So speaking of this then, if you realize this, you see on the other side, there is nothing as M or S. Isn't so?
So this equation is not homogeneous.
No, it is homogeneous. It is homogeneous. Do not think it is not homogeneous. It is 100% homogeneous. What you should understand is that at the end of this solution, there should be no meters or second in this equation, because if there was A first, the whole equation on the other side should also be equal to ampere. Do you get my point, what I'm saying?
Yes.
Okay.
So K would equal to what?
Yeah. You're not reaching there. So what you would do
We'll
is,
put it equal to 0. We'll put m
yeah,
and
so
n.
this means that m k minus 1, right? This whole thing should be equal to m0, because m0 is something that will just cancel out m, which means k minus 1 should be 0 and k will be equal to just 1. Do you guys understand this?
Yes, sir.
Right? So you can also do the same thing. You can do the same thing with s. So s1 minus k. If you want to remove s from the equation, then what you're going to do is you have to put like s0, which means 1 minus k equals to 0, and then k will be equal to 1. So whether you take it from seconds or meters, your answer would be the same, because ultimately you need to remember that this should convert to 1, because there are no units as meter and second on the other side. All right, everybody understands this? Javeria?
Yes, sir.
Yes, Yaya?
Yes, sir.
Yeah.
Okay. All right, please write this down. I think you will never be able to get anything more difficult than this. So that is the hardest one. I know. Okay. All right, so if you've written this, I want to go forward now.
Doctor, wait, I'm writing it.
So indices, if you have time, you should revisit indices in math O levels, right? Or IGCSE. Just revisit it, because if you are weak in indices, obviously this is going to trouble you. And otherwise, you just need to practice it. It's just math. It's not even physics. All right. Now,
I'm still writing this.
sorry, come again.
I am still writing this.
Okay, you can. Till you guys are writing, I just need to, get me some water. I'll be back then. Okay. Now, done. Should I go forward now? Everyone? Okay. So in 8 minutes, please do rejoin. Okay. From tomorrow, this won't be a problem. I need to update this. All right. Now, so the next question we have is this. And this question I would like to give you as homework. Okay, so you just, in this one, you just need to prove homogeneity of the equation. Pressure equals rho G, so force for area, left hand side, right hand side. I am sure you will be able to do it. But I would like to continue with question number 5. Okay. Now, in this question, it says, it's a paper 1 question, and it says a cylindrical tube rolling down a slope, inclination, and blah, blah, blah. So whenever you have units in brackets, it says that these two, these equations are homogeneous, right? So what you need to understand is that always when you see something like this, here's a tip for you. Remove brackets. When you remove brackets, you get every term separate. Like for example, 3 times L plus A square L over B equals to QT square sine theta, right? This is what you get. Now, because every term is the same in homogeneous equations, we should understand that the units on this one and the units on this one and the units on this one are all same, right? They should be equal to each other. Right now, we need to find the units for P and Q. So,
Mister,
P,
is degree a unit?
degree, no. Theta has no units. This is a dimensionless quantity, okay? So distance L should be in meters. So I'm going to write it as meters, right? And now it should be equal to the units of this term. So A is the internal radius. It's written here. So I'm going to put it in different color. So it's going to be meter square. Length is in meters and P is what we need to find, right? And this is equal to the other one on that side, which is basically Q. Q was what we need to find. T was, where's T? Find me T, time, right? So it's going to be second square and sine theta will have no units. Now, if you look at it, it means that we already know the meter unit right here. So what we can do is we can equate them one by one. So meter equals to meter and meter would be meter
Sir?
3 over P. Yes.
I want it to be plus 3L plus A square L over P.
Zahan, units cannot be added. Units stay the same. What I'm saying is the units in this term and this term, they're equal. Do you understand? In homogeneous, each term will have the same units.
Yes, sir.
So I'm putting units equal. I'm not putting the values equal. Do you understand? So about this one, so it's going to be meter, meter cube. So P can be taken there. So meter cube over meter will give you basically meter square. So it means either this, or this answer is correct. This is absolutely wrong. Okay, now let's talk about Q. So now meter is equal to Q times S square. So Q will be meter second minus 2, right? You can take second on that side. So it's going to be meter second minus 2 is this one. So it has to be P. Please have a look at it and let me know if you do understand. I'm getting something. All right. Okay, if you guys have any questions now, please do let me know. Right.
Okay.
So, okay, good. You guys have written it too? Should I go forward now? I hope you guys have printed out the thing, right? Who doesn't know what you guys need to print out in this class? Please let me know.
Sir, you have
Khadija,
sent
you-
us the sheets for 4 different topics, right?
I have sent, but I've sent 4 for now, but I will keep on adding in the file the same,
Yeah. Okay.
So as I'm adding, you should keep them, take it out as a print. Yes, Ayan.
When do we have to submit this? At the end of this week? Or?
As soon at the end of this week, as soon as we finish the topic, okay?
Okay,
You
gotcha.
should.
All right.
Because I give homework every day, 1 question, 2 questions, those are important, okay? Now, going on. So prefixes are basically one important part. You need to remember this. So prefix is there to manage units. So we have kilo. I don't like this color. Wait. We
So
have.
can you go up? Sorry.
Sorry.
Yeah, just go up very quick. Yeah, thank you.
Okay, so kilo, and then mega, and then giga, and then tera. So these are the prefix we're going to talk about. Then we're going to look at their symbols. And then we're going to look at their power. Okay. So the smaller ones are deci, centi, milli, micro, nano, pico. Okay. Now, tera, kilo is K, mega is M, giga is G, tera is T. They're all capitals. Oh my God, I should have written this here. Okay, sorry. All right. Deci, small d. Milli is small m. Sorry, centi is C. Milli is small m. Micro is U, like this, Greek one. N is for nano, P is for pico. Now the power goes like this. All the capital letters that have K, M, G, T, they have larger powers in positives, like 10 raised to power 3. Then it is 10 raised to power 6, 10 raised to power 9, 10 raised to power 12. The ones which are in smaller letters, they have negative powers, like 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 3. And then 10 raised to minus 6, 10 raised to minus 9, and 10 raised to minus 12. So these are the ones you need to remember. Okay. Now, how do you convert something? Like, for example, if you have converting a decimal number into standard form, right? So what you're going to do is, suppose the number is given like 0.0000006